discuss the global sequence alignment through the dynamic programming method. Herein, the first column and the first row is taken as empty. We are going to see about this in the very next slide. And the score in the first block is taken as 0. We fill the first column and the first row with gap multiples. The gap multiples are taken in an arithmetic progression of like -2, -4, -6 and so on. These set of scores is taken both horizontally as well as vertically downward direction. How do we basically proclaim these values? So this is based upon certain set of instructions or rules for the gap multiples. When we fill the blocks horizontally, we fill that with the score which is added with gap penalties. The gap penalties is having a value of -2 for each block, and -2 is also added to the subsequent block as well. For vertical filling of the blocks as well, the score is added with the gap penalties. Whenever we fill the gap penalties diagonally, we add the value of score to a match or mismatch. Now what is the score for match or mismatch here? Where suppose there is a match, that is A matches with A, then the score would be +1, and for a mismatch like A does not match with the C or A does not match, A is not equal to T, then the value is taken as -1. For gap penalties, the scores are defined as -2. Now let's move to the next slide where we are going to see how these set of instructions or these rules are applied for the global alignment through this dynamic programming method. So this global sequence alignment is based upon the Needleman Wunsch algorithms. Herein we are taking two hypothetical sequences, one of them having the sequence of letters as A, T, G, C and T. This set of nucleotides is taken horizontally. The other set of nucleotides is taken vertically in the downward direction and it reads as A, G, C and T. As discussed or as told in the very previous slide, the very first block is filled with a score of 0. It is having a default value of 0. And I told you in the previous slide as well, when we move horizontally, we add a gap penalty which is having a value of -2 to the score in the previous block. Now what is the score here in the previous block? That is -2. So 0 minus 2 equals to -2, and we fill it, and again when we move forward we will add -2 as well. So -2 plus -2, that will become -4. Again this -4 is added with a gap penalty of -2, that will give you a value of -6. So subsequently you are going to the value of -8, -10 and so on. So if the length of the nucleotides goes on increasing, you will see that in the subsequent stretch of this first block of grid will be having increasing values but with a negative sign. Same goes for the vertically placed stretch of nucleotides. Herein we have not yet started this alignment yet. Please note that here. These are just default values. So now we begin the alignment for both horizontally and vertically aligned sequences from the very first box, as you can see here on screen. So we will add a gap penalty to the score for both horizontal and vertical boxes in the previous box, as you can see here on screen. So in the previous box, or for the horizontal alignment, score in the previous box was -2. Then we add a gap penalty of -2. It will come with a score of -4. For vertically downward direction, as I'm pointing out here, the score in the previous block was -2, and we again add a gap penalty of -2. This will yield a score of -4. Now for downward direction, score in the previous block was 0, and herein we see if there is an alignment between the stretch of nucleotides. Of course there is a match between A to A, and in the previous slide I show you that if there is a match between the nucleotides, then we add a value of +1. So 0 plus 1 will give you a value of 1 or +1. So which among these three scores is highest? Of course the value of +1 is highest among these three, so we will fill a value of +1. Fine. Now we move on to the next box. As you can see here, for this box, the score in the previous horizontal blocks was +1, and we will add a gap penalty of -2. This will yield a value of -1. For vertical scoring, the score in the previous block was +4 and we will add a gap penalty of -2 as discussed previously. This will give us a value of -6. And again for diagonal scoring, what we see is that in the previous block the value was -2. Since there is A does not matches with T, so this is a mismatch. It means we will have a value of -1. So -2 -2 plus -1, this will give you -2 -1 equals to value of -3. Fine. So which among these three value is highest? Of course -1 is the highest here. So we will fill a value of -2. Now we again fill the next box by following this same pattern. Herein what we see that the score in the previous horizontal box was -1. We will add gap penalty of -2. So this will give a value of -1 -2, that is a value of -3. In the vertically placed above box, the score was -6. Will again a gap penalty of -2, that will yield a value of -6 -2 equals to -8. In the previous diagonal box, score was -4 and we check if there is a match or mismatch. Of course A does not matches with G. So what we see here is a mismatch. So it means there will be a score of -1. So -4 plus -1, that will give you -4 -1 equals to -5. Fine. So which among these three values is highest? -3, -8 or -5? Of course -3 is highest. So again we will select the highest value which is to be filled in this box. So this way we are going to fill the subsequent boxes. So I have already filled the boxes. Now you can also try this exercise by yourself and see if your score matches with mine or not. So I will just wait and then we will move forward. I hope you have now completed this filling of blocks within this grid. Now we will see how to do the trace back, which is the third step. We'll start from the lowermost box. From where did we get this value? Of course, we got the value from this diagonally placed nucleotide. So the trace back will be along the direction of the arrow from where we got the value in this lowermost box. So what we get, see, is we are moving from 2 to 1 in a diagonal direction. From which box did we get the value of 1 in this particular box? We got the value from the diagonally arranged box. So we'll mark this box. Now again in the next step we will see from where did we get this value. Oh, we got this value from here. Fine. So next onwards we'll check from where did we got this value of -1. Oh, we got this time we got this value of -1 from the previous box lying horizontally and not diagonally. Finally we move to the box from where we did guess value of this 1 in this particular box. We see that we've got the value from the cornermost left hand side box placed at the right hand corner. Now we will do the sequence alignment. So for this we are going to first write the horizontally placed sequence, as you can see here, A, T, G, C and T. This T matched with the lowermost T present in the vertical box. So here T matches with T. So we are going to place a black line to show the alignment. Next onwards, the C matched with C. As you can see clearly on this blue highlighted or red highlighted box. Again we got the value of 1 from 0 along the diagonally placed arrow. So here in G is matching with G. So this value of -1 to -1. How did we achieve this score? We got this score from the horizontal line. Here there is no matching between T and A. So of course this indicates that there is a gap. Please note that for each horizontally placed arrow, this will indicate a gap within the sequence which is being aligned against your test or reference sequence. Finally, we are again going to move in a diagonal direction to the upward side. So it again shows that is a match between A and A, and we will place a black line to show the alignment between the two letters A and A. Now there are few things which we must note or which we must remember here very clearly. First thing is that these diagonal arrows, they clearly show an alignment. And the second thing is the horizontally placed arrow will show a gap or insertion or deletion between the stretch of nucleotides. So I hope this concept of global sequence alignment is now clear to you. If you have any question, then just please let me know.
So I hope you have understood the topic. If you have any doubt, then please let me know. In the next video, we are going to learn about the Smith-Waterman algorithm for local sequence alignment. Thank you so much for watching this video.